Okay, so we want to practice by writing the following in scientific notation. Remember that scientific notation is a way of writing very large or very small numbers in concise form, and they usually follow the format that you write the decimal part times the exponential part, which is usually written as a decimal between 1 and 10 times the exponent 10 to the nth power. So let's see how we apply that. As we've seen as you've read in your slides, that first you must locate the decimal place, which happens to be here at the end. Then you move your decimal place until you reach a number between 1 and 10. So 1, 2, 3, 4, 5. Your n here is 5, and you rewrite your number using this form as, because we've stopped here because 1.45 is a number between 1 and 10. We don't stop here because this is 14.5. It has to be a number between 1 and 10. So we rewrite it as 1.45 times 10, and of course we put the n value here is 5. And notice our value is positive 5 because we moved the decimal place to the left. Now let us do this example. Here we locate the decimal place. This time we have to move it to the right until we get a number between 1 and 10. So 1, 2, 3, 4, 5, 6. Our n here is 6, but since we moved it to the right, it's negative 6. Let's rewrite it in our scientific notation. Our decimal part is 8.706, a number between 1 and 10, times 10 to our n power, which here our n is negative 6. Here we do the same. We locate the decimal place and we move it to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So becomes 1 times 10 to the negative 9th. So our n here was 9, and we moved it to the right, so it's negative 9. In this case, we have 2,801. We locate the decimal place. We move it until we reach a number between 1 and 10. So 1, 2, 3. Our n is 3, and our n is positive 3 because we moved our decimal place to the left. So we rewrite it as 2.801 times 10 to the third power. Okay, now and try to do the other way around. Let us write the following in standard form from scientific notation. We follow the same principles except that we work backwards. The first thing that we want to look at now is our exponent. Our exponent is positive 3. Since it's positive, it's indicating that our decimal part here is going to get bigger. And if we want to make a number bigger, we move the decimal place to the right. So we rewrite 2.1, and then we move our decimal place by our n value here, which is 3 times to the right. 1, 2, 3. Now, since we ran out of decimals, we fill in the loops with zeros. So this becomes 2100. Here, our decimal place is negative 4, right? Which indicates that our decimal part is going to get smaller, and we're going to move our decimal to the left to make it smaller. We're going to move it to the left by 4 times. So we rewrite our value, and then we move our decimal place 1, 2, 3, 4. We place our new decimal place here, and again, since we ran out of digits here, we just fill in the loops with zeros, and then we always add a 0 to the left of the decimal place as a placeholder. So 0.000966. Here we look at our exponent. It's negative 10, so the negative means move it to the left, and the 10 means 10 times. So here's our number, and then we locate our decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like we're running a little bit out of space. We add our 0 here, and again, since we ran out of digits, we fill in our numbers with zeros. And we rewrite them, see, to make it neater. Make sure you write the correct number of zeros, and then that shows to us why it's so good to use scientific notation, because we don't have to deal with all these zeros. In this last example, we rewrite our number as 2.99. We look at our exponent. It's positive 8. That means we move our decimal place to the right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. We put in our 6 zeros. And so we rewrite our number as so.